Today I'm going to show you how to find factors of a number. Let's start with distinct factors. A distinct factor is simply a list of all the factors of a certain number. So let's start with the number 48. I know that 1 goes into it because 1 goes into all numbers. And I know that 2 goes into it because it's even. What about 3? Well, if I use my divisibility rules, 4 plus 8 equals 12. 12 is divisible by 3, so 48 is divisible by 3. 4 times 8 is 48, so I know 4 will. And 4 times 12. 6 times 8 is 48, so I can put both of those. Now for 3, I would just have to divide 3 into 48 if I didn't already know it. Which is 16, then 24, and 48. The difficult thing about distinct factors is that it's easy to leave out a number if you don't know all of the factors already. So let's look at some methods that make it easier to find all the factors. The first one is a T-chart. You simply make a chart that looks like a T, and you list the factor pairs on the chart. A factor pair is a pair of numbers that multiply together to get a number, such as 1 and 48. 2, 24, 3 and 16, 4 and 12, 6 and 8. If there's not a number higher than 6, but lower than 8 that go into 48, then you know you're done. The rainbow method is very similar to the T-chart in that you list factor pairs, but you list them horizontally like distinct factors. 1 and 48. And you connect them with a rainbow. 2 and 24. 3 and 16. 4 and 12. 6 and 8. The last method is area models. Area models use rectangles to show factor pairs. 1 by 48. 2 by 24. 3 by 16. And these are not drawn to scale. 4 by 12. And 6 by 8. The other thing that you can use factoring to do is find out if a number is a perfect square or if it is a square number. Now, 48 did not have a number that was listed on both sides of the T-chart or a single number on the rainbow method. Let's take an example that is a square number, such as 16. If I do a T-chart, I know that 1 times 16, 2 times 8, and 4 by 4. I can see that there's a 4 on both sides of my chart. When this occurs, that means the number is a perfect square. Let's look at it a different way. On the rainbow method, 1 and 16, 2 and 8. We don't put both 4s down, so we just show that 4 is times itself. That's what makes it a perfect square. You could also show this with the area models. 1 by 16, and this would be half the length and twice as wide. 8 and 2. And then if we were drawing to scale, this would be a perfect square because it is 4 by 4.